My name is Max. Welcome. These are my associates, Nathan, Jacob. Today, we're here to talk about our robot, the Mangler. The Mangler is a 4-degree of freedom manipulator, which is controlled by an Arduino microcontroller interfacing with a ROS installation on this laptop. My associate will now take you through the code and how it is controlled. There are two main ways that you can control the manipulator using Python scripts. The first is the keyboard, where a user is prompted to enter a set of angles and the manipulator will move to the specified position within bounds. The second is a talker, which takes input from a joystick and publishes it to a ROS topic. The Arduino is listening to the ROS topic and takes that input and moves the manipulator to the desired position. We have implemented limits with both the keyboard and the talker. So when the input is received, it is checked for each servo motor, making sure that it is within the specified bounds. If it is over the limit, it is set to the upper limit, and if it is below the lower limit, it is set to the lower limit.
To begin, you must first install Linux on your computer. Then, download and install ROS. This is required in order to make the Arduino microcontroller communicate with the servo motors on the robot. To make the Arduino run, you must also install the Arduino code and program. Write your code and upload it to the Arduino via a USB cable. Finally, write, update, and run your Python scripts. These are required so that you may use the keyboard or a game controller to control the servo motors on the robot. These 4 servo motors are all unique and control different aspects of the robot's movement. My associate will now walk you through the structure of the robot.
The Mangler is a 4-degree of freedom parallel manipulator. It is controlled by 4 separate servo motors, which each have their own individual function for the movement of the manipulator. A servo motor located at the base of the manipulator controls the rotation of the arm. A second servo controls the shoulder movement of the manipulator. A third servo controls the elbow movement and the up and down movement of the end effector. And finally, a 4th servo motor controls the closing and opening of the jaws of the end effector.
The limitations were set in the code by use of a for loop and if statements. We check the number of the servo motor, and depending on which servo motor it is, we enact certain limitations. For the base, it was 70 to 130 degrees. For the shoulder, it was 80 to 120 degrees. For the elbow, it was 70 to 130. And for the gripper, we chose no limitations to get the full range of movement from our gripper.
With no limitations, the robot has full range of movement as allowed by the servo motors. Each servo only has a range of motion of 180 degrees, but this can be adjusted by calibrating them and adjusting the starting position of the robot. However, there are still physical limitations when giving the robot a full range of motion.
This brings us to possible errors that may occur in the operation of the manipulator. For instance, one error occurs when the limits of the servo motors are exceeded. This causes a small voltage spike within the servos, which generates a callback error within the ROS serial node, exiting the serial node and causing it to restart. A second error occurs when the force properties of the servo motor are exceeded. The servo motors are rated to a force of 9 grams. Once this force is exceeded, a similar callback error occurs within the ROS serial node. This exits the serial node and must be restarted.
I see the blue, for me and you, and I I think to myself, what a wonderful. What a wonderful world.